A vertical wire carries a current of 50 amp due south. Calculate the magnitude and the direction of the magnetic field 2 centimeter to the rate of wire. So assume that we have the wire like that, and the electric current is going towards south. We need to find out the direction and magnitude of the magnetic field. So we can use the right hand rule. If we use the right hand, the thumb is gonna show the direction of the current, and the forefinger is gonna show you the direction of the electric current. So if you consider the left hand side of this wire, it is going into the page. If you consider the right hand side of this wire, it is gonna come out of the page. So into the page, out of the page. That's how we show it. But here it says 2 centimeter to the right of the wire. So it is coming out of the paper. Going into the paper, out of the paper. So now let's see how to find out the magnitude of it. Magnitude of magnetic field is going to be calculated using the Ampere's law. Mu naught I divided by 2 pi r. So B equals to, mu naught is the constant number, which is 4 pi times 10 to the power of negative 7. I is given, which is 50 amp, divided by 2 pi. R is the distance, 2 centimeter. If you convert it to meters, it's going to be 0.02, because you need to divide it by 100. Now let's calculate it. Let's do it without using calculator. Pi and pi cancel out. 2 and 0.02 is going to make it 4 times 10 to the power of negative 2. Then 4 and 4 cancel out. 10 to the power of negative 2, and here you have 10 to the power of negative 7. That's going to make it 10 to the power of negative 5. So 50 times 10 to the power of negative 5 makes 5 times 10 to the power of negative 4, because we have 1 0 here. With this negative 5 is going to be negative 4. So it's going to be 5 times 10 to the power of negative 4 Tesla. That's how we calculate it without using calculator. So that's how we find out the direction and magnitude of the magnetic field when we have a wire carrying electric current going south.